I have been wanting to make this video for a while. I am super excited about TanStack DB and ElectricSQL. If you haven't heard of those, or if you have and you don't know what they are, that is okay. That's what I'm going to go over in this video, both what it is conceptually, but then also walk you through an example app that I have built, and we can see how all of this works together. Let's go over what all these different pieces are. TanStack DB, it is a client-first store. It helps you manage data locally, load it up from some remote source, but then also do live queries on it locally, optimistic mutations whenever you're updating data, and it does this all in a really cool way. I'll go over that in just a bit on the diagram I put together. Next up is ElectricSQL. ElectricSQL is a way to put a service in front of Postgres, still in your private infrastructure, although I believe they have a cloud offering as well. It uses the logical replication of Postgres. Essentially gives you a very, very, very reliable, robust way to look at a live set of a slice of data in Postgres. And if you've ever tried to, I mean, most of us haven't tried to build a sync engine because it's super difficult. But if you've ever tried to mimic a sync engine, which is synchronizing remote state locally, it's an incredibly hard thing to do. Linear actually gave a talk on their custom sync engine that they built in-house from the ground up. I watched it. It's a few years old at this point. It's insane. It's absolutely insane. No one should try this. It's crazy what they had to do, and you can achieve the same thing with these tools. So let me go through this diagram, and then let me show you some example code of how this will work. So everything in blue on this diagram are your reads. Everything in red are your writes. So we'll start with Postgres and go up. So we've got Postgres. It's a database. Sitting on top of that, or in a different service layer, still within your private infrastructure, is ElectricSQL. And then what ElectricSQL does is allows you to subscribe to slices of your data. They call it shapes. And it exposes an HTTP endpoint. Now, HTTP is a really simple, quote unquote, mechanism. And it essentially does long polling to keep the data updated, which you might think, why wouldn't you use WebSockets or something like this? One of the really great things about HTTP is you get all of the benefits that come with HTTP. So, for instance, caching and cache layers. So, when the front end is pulling data down, if that data hasn't changed since it last queried from the server, if the person refreshes the page and it's doing kind of a reload, it can use all the HTTP caching, even if it's not like public sort of Cloudflare caching, even just e-tags and checking, 304 not modified, or I may get that status code wrong. Whatever the not modified status code is, to make that super, super fast on the client layer. So this exposes an HTTP endpoint. What you can then do with that is by making your own proxy to this endpoint within your custom backend, you can then do auth checks and data filters. So if you have a user that's wanting to subscribe to a set of data, inside of that proxy, you can make sure they're authenticated, but then also make sure they're authorized to access that data. So you can apply any where filters that you might need to do in order to limit the visibility of their data. One of the great things that I love about this approach, and I especially love it on the right side, is this pairing of TanStack DB and ElectricSQL does not at all prescribe any sort of way to do authentication or authorization. Some of the tools that are out there that offer sync engines and local first data for you to use that synchronizes with the server often come with not only like them kind of owning your backend and your backend data, but they often come with a proprietary authentication and authorization system, which is super, super annoying. And whether it's row level security or field level security, it may not quite fit your use case, especially once you get to an app of a substantial size. In this case, you can use whatever authorization checks you need to use and apply any sort of data filters by simply composing a where clause for a database query. All right, so that is the back end. Again, we're reading data so far. Once we get up to the front end, TanStack DB is kind of your local data store on the front end. And the real-time reads and real-time data updates can be powered by ElectricSQL and then other providers that TanStack DB provides as well as custom ones that you may want to write. At that point, your UI is able to then use live queries to live subscribe to data as it changes, and it can operate on that data as if it were local. So you can update that data locally. You can read that data locally. It becomes super, super, super fast. So that is kind of the read side of the house. Let's talk about writes. This is often, again, where if you're using some other sort of system that's trying to provide local first data or sync engines, they have a very prescribed way to do writes, and then you end up kind of like figuring out how to do database type transactions on the front end, which is very strange. This takes a bit of a different approach, although some elements are similar. So when doing writes, you can issue inserts, updates, and deletes locally with TanStack DB. So if you're doing very simple operations, simple insert of a record, simple update of a record, simple delete of a record, you can do that locally with TanStack DB. It has callbacks that then handle calling to some remote endpoint and handling those updates. Again, this is completely non-prescriptive. So you can call your own custom API for handling whatever sort of insert, update, delete endpoints you want to hit. These could be HTTP endpoints, they could be REST, they could be server functions, which would be a great one, a great use case if you're on TanStack Start, which my example here in a minute will be. You could use GraphQL, you could use RPC, you could use anything that you want. And again, with it being your own custom API, you are handling your own authentication and authorization. So let's start with the simple operations here. When operating on data locally, first, because you're writing to local data, your UI becomes super responsive and you only have like one code path to handle. If you're writing to local data and your local interface is rendering local data, you don't have to worry about kind of like that in-between loading state because it frankly doesn't exist. So once local data is mutated, TanStack DB calls on insert, on update, on delete operations to your custom API. They so cleverly implement a way to handle optimistic mutations. So you need to hang on to that temporary state of the data until the server fully syncs, right? But there could be a lot of different operations happening. So you could be doing all sorts of different things, and other users could be doing different things. And if you have a highly collaborative environment, how do you know when that one specific operation of yours came back? Because it may not be the very next tick of data, the very next update payload of data, maybe someone else's operation happening, and then yours disappears briefly and then it comes back. Like that's a very complex thing to design and handle in most use cases. There's an incredibly simple and effective approach that this stack takes here. What happens is every single Postgres transaction has what's called a transaction ID. And if you just slightly alter your custom API to, as part of its payload, return that transaction ID, TanStack DB will then use that as the identifier for when the mutation has been synced and incorporated back into the remote data. So you return the transaction ID. The optimistic state stays here. It makes it through Postgres. It replicates to ElectricSQL. It makes it through your proxy, which is being pulled by TanStack DB, which includes that transaction ID. So TanStack DB knows at a transaction level, at a database transaction level, when that data is reincorporated. So there's no blinking, there's no guessing, there's no heuristics. You get a solid, reliable identifier of when that data is updated. So, what's nice about this is you can kind of see we're developing one read path here for our data and mostly one write path. Although I have an alternative here for you as well. Let's say you have some advanced or custom operations. Let's say you have something that needs to operate on a lot of different data at once, or it's not a matter of just a single insert, update, or delete. Your UI can still call whatever custom API that you want to call. And then at that point, because the source of truth is Postgres, it really all comes back to you just have to update Postgres. That's it. You don't have to do all of the writes or updates through TanStack DB. You can do offshoots through API endpoints, and as long as it's writing to Postgres, which everything should be, then that will sync back up through your read layer. So this offers you incredible flexibility with having your default option of let's do the simple CRUD like operations in TanStack DB. But for the more advanced things, going the custom route, and it's still syncing back through TanStack DB. So that is really, really cool. That means here that TanStack DB is not requiring you to follow any sort of paradigm here. You could adopt it incrementally within your app. It doesn't have to take over everything. I mean, that's what's really cool about this. We have in our app Baton that we're building, we're using this setup for our AI interactions. So when you're chatting with Baton, we've got things that could happen while this AI response is coming back in. There could be network disconnections. You could refresh the page. Even under great conditions, you want to see the data stream in. We're doing all of this with ElectricSQL and TanStack DB, and it's working really, really well. So that is the conceptual overview. Let me dive into an example app here that I've created, and this will be open source. I'll put this up in GitHub and link to it in the description. So the app here is a debt payoff calculator. And so this is a way to put in any sort of debts that you may have, credit cards, school loans, car loans, etc. And then set a monthly budget for what you'd like to contribute to paying off those debts. And then it will give you a payoff schedule, how long it will take, an approach to take. There are two different approaches someone might often take with this, which is avalanche style. This is where you pay off the highest interest first. That's the most efficient and mathematical way to do it. Then there's also snowball style, which says you pay off the lowest balance first to kind of get that like psychological juice going of, hey, I'm crossing debts off the list. So this is a really great use case for this sort of example because I have really two different data models in this system. One is a workbook, which is kind of everything you see here. It represents almost, think of like a spreadsheet. And then the next thing in the other data model is your debts. Those are linked to a workbook. You have all of these different rates and balances on them. The settings for how you want to do this is saved on the workbook itself, so your monthly budget, your strategy, etc. And then as you make changes here, all of this data changes and the table recalculates, etc. You can say, okay, well, I don't have this personal loan anymore, so I'm going to delete that. So everything's going to come back in here. We've paid off a few thousand on the car loan, so I'm going to update that. That now recalculates all the data. And if you were collaborating with someone on this, y'all could pull up the same screen, see that data side by side. In fact, let me take a look at that here. So if we're looking at this demo data and I am increasing our payment, I can see that our timeline is shortening, our total interest is going down. I'm making this change locally here within my browser. It's syncing back up to the server. It's going back through ElectricSQL. All the clients who are querying this data live are receiving updates from ElectricSQL, and their TanStack DB is updating the local state within the browser. So you get with this setup really real-time collaboration and sync almost for free. You have a few trade-offs, but almost for free. So again, let me change these balances. I'm going to change this balance. These rows will reorder. You can see that happen on both sides. I mean, you can see how incredibly fast that is. As soon as it saves on the right, it happens nearly this. Those animations are almost in sync. That's how fast it is, even going through that whole stack. So this is the example app. Look, I can rename this. I can say these are our joint finances. That renames it over here. I can go back. I can see my workbooks here. If you have more than one workbook, maybe you're like helping a friend with these sorts of things, then you can have multiple workbooks here. But yeah, so that's kind of the example app. Let me walk you through some of this code and how it works. So the first thing you do in TanStack DB, well, after you set up your infrastructure, you have to get ElectricSQL running, which it runs easily in Docker Compose. In fact, I'll just show that to you here. So I have a pretty standard Postgres setup, although we are configuring it for logical replication. And then we have our ElectricSQL instance here. It is connected to the Postgres instance, and it exposes a port that, again, would not be publicly accessible to the internet in production. This would be exposed to your local private network within your infrastructure, and then your backend exposes it through a proxy. That's the ElectricSQL side. Let me flip concepts for a bit. Let me go back to the top of the stack, and we will look at the UI side of this first, and then maybe we'll work our way down from there. So the first thing you do in TanStack DB is, oh my gosh, these hovers. The first thing you do in TanStack DB is you define what's called collections. And collections you can really think of as a table. So we have two collections in this app. One is workbooks and one is debts. So we have our workbooks collection here. You map that to a ZOD schema. So if I take a look at this, I've got our workbook schema here, ID name, monthly payment, strategy, created at, updated app. That helps TanStack DB locally to validate your data and know the expected shapes and provide all the nice typings that you might expect in TypeScript. The shape options, this is kind of ElectricSQL speak, and it allows you to have a way to filter your data. In this case, we're just saying that we want the table workbooks, and actually on the server side in our proxy, that's where we are further limiting the data to only what this user has access to. I'll get to that in a second. Then you define callbacks for onInsert, onUpdate, and onDelete. This is where you connect up when something happens to our local data on the front end within TanStack DB. How do we write that to the server? So in this case, all I'm doing is I'm calling three different server functions that I have. One called create workbook, one called update workbook, one called delete workbook. Those are server functions that authorize the users through our betterauth setup that we have here, writes to Postgres, and it returns the transaction ID. In fact, let's dive into that a bit. So let's take a look at those server functions. What would be a good one here? Let's do update. So we have an update workbook server function. We're creating a TanStack start server function. We are validating the input. So we want to expect a workbook. These hovers are driving me crazy. We want to expect a workbook. I'm not sure how to turn those off. We want to expect a workbook, pick off only the keys that we want, and then also say that the user can pass in partial data. So if you're just updating the name of the workbook, only provide the name. We don't need you to provide all the values. In fact, that's worse because then you may be overriding someone else. So we're just using our same, it's actually the same workbook schema. So we're sharing this Zod schema with both the front end and the back end, which is really cool. Then down in the handler, we have an authorization check to authorize this user for the workbook. Again, this is our own handwritten, home baked authorization check. Then we're doing a Prisma transaction here to both update the workbook and get the transaction ID. And then as a part of the return, we are returning that transaction ID. We actually don't need to return anything else. I'm just doing that here. The local client has already updated locally, and this transaction ID provides that optimistic endpoint of when TanStack DB can utilize the live data once this transaction flows through the whole system. If you're familiar with Prisma, you may be like, oh my gosh, how do you get that transaction ID? Well, it's not baked in. You have to do this a little bit manually, but as you can see here, I just have a nice little utility function that I've hidden it within, and then you can use that throughout. But let me show that to you here as well. I'll pull this down here. So again, we're doing this inside of one Prisma transaction. We are using the built-in Postgres function for getting the transaction ID and simply returning that back. And that's it. That's what it takes to perform the writes to our data. And yeah, it's pretty easy like that. I did skip over what the actual write looks like in code. So let me show you what this new workbook button looks like. So again, we defined a workbooks collection here, which is a local collection of where to connect up to in ElectricSQL, what to do for callbacks of saving the data to the server. What does it look like to actually work on local data? So this new workbook button here takes that workbooks collection and runs an insert on it. So we're inserting just a UUID that we are generating here, utilizing those new Postgres UUID v7s in the latest Postgres version 18, which is cool. And setting some default values here. This is getting validated against our Zod schema. So this is assured to match the schema that we want. And then we're going ahead and navigating to that workbook. So this workbook will exist instantly in our local collection. And meanwhile, it will be saving to the server as well. All right, so that's what an insert looks like locally. Again, TanStack DB then takes that, calls this on insert callback. That then lands at our server function, which actually does the inserting of data into our database, again with auth checks, again setting all the proper information. So that's a good example here. We're not setting an owner ID for this workbook on the client because that's not something you want to rely on the client to do. Instead, we're setting who owns this workbook on the server side based upon who made this call. So that's a really great example of how you can handle the safe things that can safely be done on the client, but then handle the security mechanisms on the server. Okay, those are the rights, and I'm kind of surprised I started there, but let's then go back through the read layer now. Okay, so I think you probably know how Postgres works if you're watching this video. Again, ElectricSQL is a layer on top of Postgres. Then let's take a look at our proxy. So again, we have Postgres, ElectricSQL, then we're running a proxy here, which eventually makes it up to that TanStack DB collection that I just showed off. So let's look at the proxy. So the proxy here is just simply an HTTP endpoint that the client is able to call. TanStack DB handles calling this for you. We are authenticating the user through BetterAuth, throwing errors if they're not authenticated. We are then taking these search parameters and applying some these popovers. How do I get rid of these? Okay, I think I figured out how to get rid of the hovers. We'll see. So here on our custom proxy, we are defining what are the allowed tables that the client is able to listen to. So again, we're trusting nothing from the client. We are doing server-side checks on everything to make sure that they can't just essentially query the database for anything they want to see. So the client can only access workbooks and debts. And then even within that, let's go to workbooks, that's simpler. For workbooks, we are applying a where condition that gets passed to ElectricSQL that says only return workbooks where the owner ID is the current user ID. The client doesn't set this. This is set by the server and server only. So it ensures that this client is only getting workbooks that they have access to. Similarly, for debts, we only want to return debts that are a part of one of that user's workbooks. I'm not honestly 100% sure if this is the best approach. I would be interested if any TanStack DB people or ElectricSQL people are watching this video, what the recommended approach would be. So I'm still exploring this a bit. But the way I'm doing it here is I'm fetching all the workbooks for this user and then applying a where clause that says where the workbook ID is within this user's workbook IDs. I think this works fine for this approach because you're not often adding and removing workbooks for this particular app. This would be something that changes infrequently. One of the requirements of ElectricSQL is that the where clause has to be static. It cannot be dynamic data. For instance, if you are wanting to limit data with respect to time, you couldn't say, just show me the last 30 days, because the last 30 days is always changing at any point in time. You could say, return to me data that is 2025 or newer, because that is a where clause that doesn't change. It's always going to be 2025 or newer. These are also considered static where clauses. There may be a better term for it, but these are also considered static where clauses because even though your list of IDs may change here, this rendered where clause doesn't change. And if your set of IDs does change, it's actually just considered a new shape within ElectricSQL, and that creates a new subscription on that side. So this is an okay approach. It has one or two sort of issues that you have to deal with this because when it's polling, the current poll may not include a brand new workbook that is appearing. That brand new workbook would only appear on the next HTTP call. So for instance, you may have noticed I'm doing one little thing in here on, may not be able to find it. One little thing on here on navigate, I'm actually reloading the document when navigating to this new workbook so that when it subscribes to the debts, that new workbook ID is a part of that collection. I'm sure that there is a better way around this. Again, it's fairly new to me too and fairly new technology, so I'm awaiting best practices on how to do this. But that is really the proxy. It then takes this information, passes it on to ElectricSQL, and returns the ElectricSQL response that it has. So to show you what these calls look like, I have refreshed the page here and I've opened up Network Inspector. This is calling our proxied ElectricSQL endpoint. It's providing some conditions here. So our condition of give me the table workbooks, but then it's also giving an offset of data. So an offset of -1 is saying give me everything from the beginning. And you can see various calls come in here as this polling happens. Now this polling, as you could see when I had the screen side by side, is very efficient, very quick. And these are all 200, but sometimes these will come across as actually cached, and it doesn't actually have to return the data from the server. It can just return that not modified status code. So if we take a look at the payloads, you can see here are the workbooks, and these are only my 3 workbooks. You can't see anyone else's workbook, and they come in like so. So if I come over here and I say want to rename this to electric demo, and I'm going to hit enter there. If I look at one of the things that just came across, here is the update from the workbooks table. The value came across. It was this ID, electric demo was updated, and the updated at timestamp was updated. So it's only returning to me the partial record updates and then merging those in locally. Again, if I had a network disconnection, if I went online, offline, etc., it's able to reliably merge that data on transaction IDs and these, I believe these are timestamp offsets, like replication log timestamp offsets, not just like updated at timestamps that could be manipulated. Now, one of the critiques of when this first came out is that what essentially happens on page load is that it loads all of the data, all of the data you have access to. So, all of my workbooks, all of my debts, no matter if I'm looking at a particular workbook or not. Depends on how you have your collection set up, but for the most part, it's loading all of the data up front. Now, for this type of app, that's totally fine. This is a very small amount of data. And actually, for most apps, you can go further than you think you can as far as what you can load up front, especially if you're doing so in an efficient manner, and especially if you're doing so with the caching set to where it's attempting to upload all the data, but really all the data doesn't have to be transmitted over the wire if it's even just cached locally in the browser by the built-in HTTP caching. Like, we're not talking build your own cache here. That becomes incredibly efficient to do beyond just that first load. Now, there's this new version of TanStack DB that was just announced and released, which is TanStack DB 0.5, I believe. It has the ability to, from your queries, pass the parameters on through to the read query. So I'm not sure if ElectricSQL has quite gotten up to speed on that or not. I don't know as of the recording of this video, but they are making it to where you do not have to load all of the data up front. So if you have any hesitations like that, don't worry, it's actively being worked on. Now, I'm realizing as I'm telling you this, actually, I haven't showed you how you read the data from the components. So let me go back to the dashboard here. That's one of the coolest things. Almost missed it. Okay, so let's say we want to get the data for these workbooks, and I'll flip over to debts as well. TanStack DB provides a hook called useLiveQuery. And it looks roughly like a database hook where you say, I want to query from workbook, and you give it that you want to query from the workbooks collection. And you want to order by, and in this case, I'm ordering by updated at descending. So electric demo is the one I just updated in the other window, by the way. Demo 2, let's say I make that demo 3. I'm going to go back here. Now it's the first one because it's the most recently updated. This query gets re-executed and recalculated anytime the underlying data changes, which is super cool. And it does it in, again, an incredibly efficient manner. They've made a lot of claims to the efficiency of this and that it's not a naive implementation. So even if it's a large amount of data, this is supposed to be very, very efficient. So that's what a query looks like, a simplistic query. Let me go back into, let's say, the workbook view itself. And similarly, again, I'm getting the workbook here. You can even do a find one. In this case, I only want one workbook. And now I want the debts for this workbook. So I'm going to say, do a live query from the debts collection, where the debt workbook ID is equal to this workbook ID that we're looking at. And then right now I'm ordering the debts by name. I'm later in this component processing these locally to do some like ordering by balance and things like that. So yeah, you can still process this locally once you get the data from useLiveQuery as well. Now, one thing I don't have an example of in this app are some of the more powerful mechanisms of useLiveQuery in particular is joins. This is a very common thing that you might want or need to do on data. For instance, let's say you've got user posts. You've got a collection of users and you've got a collection of posts. You can then say, I want to query from users, join it on posts where the user ID equals the post ID. Then you get back a return set of rows with those joins together. So you don't have to build out endpoints for users, endpoints for posts, endpoints for user posts, do all that join together. Like this is something we would often do in GraphQL and make these fields within fields and do those joins there. In this case, you could just simply expose the raw data underneath the hood, again, authorized, limited, etc., for users and posts, and then join that on the client. And again, it's supposed to be very, very efficient. And you can do all sorts of things. I didn't even know there's left joins. There's left joins on here. Oh gosh, wow, they have a lot of different types of joins. Subqueries, that's interesting. Uh, a lot of different things. It's not trying to replicate SQL, but it is trying to provide you the ergonomics that you might be used to and the things that you want to see. And because you have data that can be changing in multiple places, like let's go to the simple example again here. We've got user posts. Well, in this case, a user's name could change, their profile picture could change, a post could change, its title, its body, etc. Anytime any of this data changes in either of those connected relationships, then you're going to get back updated data from your live query, which is really, really cool. Again, if you're implementing something like this via GraphQL subscriptions, most of the time, if some other like related model changes, you're often not going to get a subscription update unless you just like really go to the ends of the earth to figure out all the different related things to update a subscription for at the application layer. It's just not often going to work like that. So being able to handle that via TanStack DB, handle that via those disparate updates coming in on a variety of models is really, really cool. So that is a whirlwind tour of TanStack DB and ElectricSQL. Again, this is as far as like web development or even beyond web development. This doesn't have to be web. This could be on, React Native as well. This is one of the things I'm most excited about right now. Live collaborative data is something that we're kind of all working towards. Apps are expected to be collaborative. They're expected to be reliable. They're expected to be fast. And it's hard to achieve all of those things at once with our traditional tools that we've had. This provides a really nice, incrementally adoptable solution that builds off of tools you're most likely using. A lot of you are probably using Postgres. A lot of you are probably using React. So there's not a lot of requirements here to get started. Doesn't have to take over everything. You can bring it in piece by piece. And it doesn't require you to follow any specific, again, authorization or authentication mechanism. You can build that in for the needs of your app. So give this a try, check it out. I'm going to post the repo for this example app on GitHub, and I'll link to it in the description below. I am also still new to this, so I am looking forward to learning more and more and more about this. It's rapidly being developed on by some incredibly smart people, and I'm excited to see what comes next. Friendly reminder, if you made it this far in the video, thank you for watching. I am hiring TypeScript backend and front-end developers. So check the description for those job posts if you are interested. We are hiring remote first positions within the US. So If that may be you, I'd love for you to submit an application. All right, have fun exploring. I'll see you in the next video.